Okay, so today we're going to talk about ionic solids versus covalent solids. So your ionic solid, common one, salt, NaCl. And it's made up of sodium ions attracted to chloride ions. And the thing is, you've got this structure. That's my dog, don't worry about that. That just repeats over and over again. I'm going to use two different colors to show you that. And so it's hard to draw these things 3D kind of, but you know, if you do it kind of like this. So you've got this kind of repeating pattern here, and you know this goes on just sort of ad infinitum. If you have just like a little crystal of salt, you have that back and forth, okay? You know, and it's just like millions upon millions of times. And so what that leads to is these compounds are brittle. They only exist really in the solid form. You know, you don't have salt gas or salt liquid. I mean, you can make salt molten, but it takes a tremendous amount of energy. You can't melt salt on the stove. They're brittle crystals. They have tremendously high boiling and melting points. But because they are made up of ions, they will dissolve in water because it's a polar solvent. And when they dissolve in water, they conduct electricity. So this is kind of what you need to know about ionic solids. They're made of ions, like salt is made of sodium and chloride ions. Now, a mistake you don't want to make is it's not like this sodium gave an electron to this chloride and then, oh, they're attracted to each other. No. Okay, this sodium lost an electron, became an ion, and then it's just around chloride ions, okay? And then salt is made. Don't think about it, because that would be, if you think about it as like a one-to-one, you know, and you pair them up, that's too much like covalent bonding. They're brittle crystals. They are crystalline. They have much higher melting and boiling points than anything you're going to see in a covalent solid, except for maybe like a covalent network solid, which we'll talk about in a later video. But, you know, like your common covalent solids like sugar. Sugar you can melt on the stove. Ionic solids, you can't melt salt on the stove, okay? Don't go try it. Trust me on that one, okay? And then when you dissolve this in water, because it forms those ions, and those ions are charged, it will conduct electricity. Now, a covalent solid, oh my gosh, this is going to... I'm not going to draw the whole thing, but that would take forever. But just to kind of show you. Okay, so what we have here is these are covalent bonds. You can look at the videos for covalent bonds. And so the sugar is held together by covalent bonds. But each individual sugar molecule is its own thing. So this is its own unit, that's its own unit, that's its own unit. And they're not held together by that big ionic attraction. And so these guys have lower melting points, and they are also all stable as a unit. And so when you dissolve sugar in water, it won't conduct electricity. So when we look here, and one of the labs we'll do, hopefully, is we're going to look for ions in water. And if you dissolve salt in water, you get these ions. It conducts electricity. It'll light up a little light. If you dissolve sugar in water, it won't conduct electricity, and you won't see the connection made. There won't be electricity conducted, and it won't make the connection. So for covalent solid, they have lower melting and boiling points, do not conduct electricity in water, and they're just not as overall connected as the ionic crystals. So for a bonus video, I will do the full structure of the C6H12O6, and I'll put that up afterwards.